we have the 2018 paper 2 question 18, and this one definitely caused a lot of issues. We'll do part A in this video and B in the next one. So the idea is that we have two containers or cartons, and we're given the depth or the height of each and the maximum volume or the maximum capacity of both of them. And what you have to do is show that the two cartons are not mathematically similar. Now this is odd because normally you're told in a question that they're mathematically similar, and you have to then calculate either a volume or a length or find out some information. This question is a bit different. You're given all of the information, the dimensions, you're given all of those, and you're told to show that they're not mathematically similar. So what we're going to do is there's two ways, there's actually 5 ways that they do this in the marking scheme, but I'm just going to focus on the first 2 because the other 3 do tend to get complicated, and most pupils would have used one of these 2 methods. And methods 3 to 5 you will most likely make a mistake on because they're very hard to do. So I will focus on 1 and 2, which are much easier and much safer. If you want to pause the video, have a go at it, but I'm going to continue. So what we're going to do for the first one is we're going to fix this. So we have this one, and we're going to pretend that the one on the right hand side is mathematically similar. So we'll say, suppose that suppose they were mathematically similar. And you do have to write this line because the question does say that they're not, but we're going to suppose, what if they were? Then we have the small one, and we're going to find the corresponding volume of the large one if they were mathematically similar. Suppose they were mathematically similar. And what we have to do first of all is find the linear scale factor. In this case, it's going to be the large divided by the small. So we're going to call the linear scale factor. So linear scale factor is LSF for short. So it's LSF. And what we're going to do is we're going to do so this is the large depth divided by the small depth. You want to specify which one you're doing, because you can do the large divided by the small or the small divided by the large, but it will vary depending on which one you're doing, because if you start with the small one and find the volume of the large one, you do large depth over small depth. I will show you the other way in which you do the small divided by the large. and that's going to be 24 divided by 16. There's no need to evaluate this at the minute. You can just write down 24 over 16. Now, we then have to get the large volume. So the large volume would be, we're not going to write equals, we're going to write would be, because technically they're not mathematically similar, but we're finding what it would be. That'd be 24 divided by 16, and because it's volume, because it's volume, you have to cube the linear scale factor, so that becomes cubed, and you multiply this by the small volume of 576. So you then want to plug this in to a calculator. You have access to a scientific calculator in this exam, so you want to plug all of that in and make sure to keep a few decimal places. And we get 1944, so we get this exactly, and there's actually no decimal places. I thought there would be. Centimeters cubed, and that's a volume, but we're told in the question that the volume is 1125. So what we then say is, and it's very long-winded, but you do have to write this, but the question says, large volume is 1125 and not 1944. So because that's the case, then the initial statement crumbles. It makes no sense. So they can't be mathematically similar. So we then say, hence not mathematically similar. We've done one way of doing this, but the other way is that we take the large one now. So I will take the large one, and we have the information regarding this one. So we have the depth and the volume. But what we want to do is we want to then find what the volume of the small one would be if they were mathematically similar. So what I'm going to do is I'm going to start the whole thing again, and I'm going to say, suppose I'm going to write MS. Do not write MS in the exam, but I'm doing it for shorthand because we've already done something similar. So suppose they're mathematically similar. We want the linear scale factor Again, you write linear scale factor, not LSF. That's going to be the small depth. So the small depth divided by the large depth. And the small depth is 16 and the large one is 24. And we then want to find, if mathematically similar, the small volume would be and we take the 16 over 24. Again, this has to be cubed. And we then multiply this by the volume of the large one, because the volume of the large one is fixed. That's what we do know, and we're using that information to find the small volume. Again, you plug this into the calculator. And what you get is 333.33, and the units are centimeters cubed. You don't have to do both of these methods, of course, you just have to do one. But the idea is that the volume that the small one would be, if the large one is fixed and they were mathematically similar, would be this volume. But the question says, I know this question is a lot of writing, so I apologise about the long gaps I'm taking, but you've got to write all of this down. So the question says that the small volume is 576. So, yeah, that's it. 576 centimeters cubed, not 333.33. So they're not mathematically similar. Again, because we've already done this, I will put MS. I repeat, do not write MS in the exam. Now let's have a look at how the SQA would mark both of those methods. In the first one, you would get the first mark for the linear scale factor. You would then get the second mark for knowing how to find the large volume if the small carton is fixed. And the last mark is for everything else, including the justification and the explanation. And you have to link it back to the question. So we've got here that the volume we found, the volume we calculated is the volume it would be if they were mathematically similar, but that doesn't match up with the volume given in the question for the large one, so they can't be mathematically similar. The marking is very similar on this one. It's a mark for this it is then a mark for this, and it's a mark for everything else. So you can see that the multiple ways that they do this. So I hope you found this video useful. I'll leave this up one last time. I will leave up this method. And thank you for watching, and best of luck with the studying.